These stats here are from a Scrapey project set up with 32 concurrent requests, and as we can see it took just over 160 seconds to run around 1400 requests. But what I want to know is, can I make this faster with distributed scraping? So distributed scraping is where we run multiple instances of our spider over many different machines, or in this case multiple DigitalOcean droplets, and we have them pull URLs from a central queue. Our queue is a Redis instance and we are using Scrapey Redis to manage it all. Given the main benefit of distributed scraping is horizontal scaling, how many nodes will we need to beat the standard Scrapey project? So we're at 45 pages through. I set this to 50 something pages, 51, well, that's changed. I set this to 50 pages, I think, or 51 pages. So we're soon going to have hit all of the URLs in, and you'll see that when this code stops running. Okay, so this has stopped running, so we've pushed all of the URLs into the queue now. And we actually have only 400-ish left to get through. So these are working their way through them pretty well and pretty quickly. We're at just over 2 minutes. And all the URLs are finished and any of the spiders have all stopped doing anything and everything's good. So that was 176 seconds. So running it like this was actually 15 seconds slower than running the equivalent on Scrapey on a single node utilizing async. Given we're going to be scraping from multiple nodes, proxies are going to be essential for our use case. With Proxy Scrape, the sponsor of today's video, we have access to high quality, secure, fast and ethically sourced proxies that are perfect for this use. There's 10 million plus proxies in the pool ready to use, all with unlimited concurrent sessions from countries all over the globe, enabling us to scrape quickly and efficiently. I pretty much exclusively use residential proxies as these are the best options for beating any anti-bot protection on the sites we're scraping, and with the auto rotation this is just so simple to put in and helps us avoid being blocked and gives us access to the data we need. It's only one line of code really to add, and Proxy Scrape will handle the rest from there. And any traffic you purchase is yours to use whenever, as it doesn't ever expire. This is really, really cool. Other options though, if you just want throughput, then there's loads of data center proxies available, unlimited bandwidth, 99% uptime, no rate limit, and with IP authentication, making them very attractive use for the right option, the right use case. So if this all sounds good to you, go ahead and check out Proxy Scrape at the link in the description below. Now, let's find out how many nodes I'll need to make this faster. This is 10 separate nodes, all connected to my Redis queue. Each picks up a new URL, scrapes it, and returns the data. But even in this case, even 10 nodes wasn't enough to be faster. So what is the point of distributed scraping, and is it even worth it? The idea is that we can scale to near infinite amount of nodes. So let's say our 1400 URLs had 1400 nodes to scrape from. We could do this in just a few seconds. However, this is exactly how DDoS attacks work, distributing requests over multiple nodes and flooding servers to take them down. This is bad and we do not want to do this. This is not what we're trying to achieve. Okay, so we've got all of our nodes ready. They're all waiting for URLs, so let's start putting some in and see how long it takes. Okay, so the script's running, and we're going to start to see the spiders picking up URLs now. We can check a few of them over here. Red requests. This one needs to scroll down. Red requests. Okay, cool, it's working. So let's see how many URLs we have going on in here. So there's 160, 150, 170 in the queue. So I'm hoping that this one is going to be quicker. I think it's probably going to take still about 90 odd seconds. Just given the fact that it takes about a minute or so to get all of the URLs into the queue, but we should be able to be picking them up pretty quickly and zipping through them with all of our extra nodes. So let's go ahead and wait and see how long this takes. So all the URLs are done now, and we're up just over a minute, and there's only 300 left in the queue. So this is probably going to be not quite 90 seconds, maybe slightly over, with about 200 to go. So this is obviously significantly quicker, and it's all finished, all the URLs are done, and that was 90 seconds, 91 seconds. Much quicker than the 161, and that was with just about 20 nodes. I think I ended up with 19. So I'm going to call that a success. I'm not going to push this any further, but I'm going to say that this has proved the concept, that this is possible, and we're going to talk about this a bit more. So my goals for this project were more of a proof of concept. I wanted to learn and see it working, but the truth is distributed scraping like we're doing here just isn't worth the cost, time and complexity. To understand why, we need to have a look at what is actually causing us to hit a speed cap when we're scraping data. Scraping is restricted by your network speed, not your computer speed, so it's network bound, not GPU, not CPU bound. This means distributing a simple scraper like this will have negligible benefits. But distributing a scraper that relies on browser automation will have speed benefits. Because browsers are resource hungry, moving them off to separate hardware to perform their tasks, using a similar queuing system, we can expect to see performance gains. But this in itself is incredibly time consuming and complex to manage. Running a fleet of browsers is a no easy task. That's why there are so many companies offering you API access to their browsers that will return you HTML. What issues did I come across when I was trying to run this? Well, even with my toy example here, I started to see some of the initial issues come up. I would need to write my own tools to manage bringing up the VPSs online, distribute code correctly and run it. It would need to be able to update any code changes and have a way of managing any of the nodes that went down or my spiders that stopped running. Geolocation is also important. Initially I set up my Redis instance in the US, but the servers were in the UK, meaning a time delay of several milliseconds each round trip. Every URL picked up and item pushed back cost time. This was easily rectified, but there is definitely still some latency there. Then there's the cost. Running a single Scrapey instance at home is basically zero cost, but a Redis instance and multiple servers all cost money. So let's up the node count now and see if we can at least beat the single async scraper's time over these 1400 URLs. This was a fun experiment and a good learning process. And will I use this method in the future? Maybe, but for this use case, no. If you want to see a completely Scrapey project that runs async on a single machine that beats all of this, you'll want to watch this video now.